Intermagnet. Intermagnet, the International Real-Time Magnetic Observatory Network, is a worldwide consortium of institutes operating ground-based magnetometers recording the absolute level of the Earth's time-varying magnetic to an agreed set of standards. Intermagnet has its roots in discussions held at the Workshop on Magnetic Observatory Instruments in Ottawa, Canada, in August 1986, and at the Nordic Comparison Meeting in Chambon-Lafort, France, in May 1987. A pilot scheme between OSCE and BGS was described in the sessions of Division V of the International Association of Geomagnetism and Aeronomy at the 19th General Assembly of the International Union of Geodesy, Canada, in August 1987. This scheme used the GOES East satellite to successfully transfer geomagnetic data between the two organizations. Intermagnet was founded soon after in order to extend the network of observatories communicating in this way. 62 different institutes are now members of the Intermagnet Consortium, and since 1991, data have been contributed to Intermagnet from approximately 150 observatories. Intermagnet is a member of the World Data System of the International Science Council, and it is closely associated with the International Association of Geomagnetism and Aeronomy. Intermagnet is organized into an executive council, formed of representatives of its founding members ENARC Canada, IP France, BGS United Kingdom, OSCE United States of America, and an operations committee formed of members from many institutes concerned with geomagnetism and with operating magnetic observatories. The Operations Committee handles applications for membership of Intermagnet, implements updates to the technical manual, and oversees the maintenance of standards and the annual publication of data. Intermagnet operational standards and other technical information are summarized in the technical manual. Data. 1-minute resolution data time series are available from all IMO. These are described as definitive data, as they are not subject to future reprocessing or recalibration and therefore represent Intermagnet's gold standard data product for scientific and other uses. Definitive data are therefore considered an accurate representation of the vector geomagnetic field and its time dependence at the location of each IMO. Reported or raw, unprocessed data are reported promptly from each observatory for some stations within an hour of acquisition. The 1-minute resolution data are time-stamped to the start of each minute and are derived from faster sampled data according to digital filters that accord with the technical standards for 1-minute data. Intermagnet introduced as of 2016 a new set of standards for the measuring, recording, and reporting of 1-second sampled data by IMO. Intermagnet also introduced in 2013 a category of quasi-definitive 1-minute data to encourage the prompt reporting of observatory data that are demonstrably closed. Quasi-definitive data are intended to encourage the uptake of ground-based magnetometer data alongside the high volumes of satellite survey data, particularly for the construction and geophysical interpretation of regional and global magnetic field models. The IMO must send reported and adjusted data within 72 hours to Geomagnetic Information Nodes GIN, located in Paris, France, Edinburgh, United Kingdom, Golden, USA, Kyoto, Japan. In practice, however, many IMO distribute their data to the GIN much more promptly. Intermagnet data are available in several formats and data are published annually. Prior to 2014, definitive 1-minute data were published on CD or DVD and each IMO received a copy of all data. Until 2016, IMO data were made available on USB memory stick, additional copies available on application to the Intermagnet Secretary. For the 2016 data release and to mark 25 years of digital data, Intermagnet released a final USB stick containing all data published since 1991. For later years, definitive data are available in digital form from the website only. Intermagnet has introduced the concept of the Intermagnet Reference Data Set, or ERDS, to mark the annual release of data on the website and containing all IMO for a given year, plus all data from the start of Intermagnet, including any corrections and adjustments to data released with ERDS for previous years. As a concept, the ERDS probably most closely resembles the update cycle of the IGF. Recent developments 2014-2019. Metadata. Intermagnet has developed a metadata schema as part of its plans for data interoperability. Web services. Intermagnet data are now retrievable and accessible via API. Quasi-definitive data. Quasi-definitive data QDD are data that have been corrected using provisional baselines. Produced soon after acquisition, 98% of the differences between QDD and definitive data X north, Y east, Z down monthly mean values should be less than 5 in T. QDD are intended to support field modeling activities during the modern satellite survey era, providing extra constraints on, for example, models of the field secular variation. Data licensing. Intermagnet data are subject to conditions of use and are licensed under Creative Commons CC by NC. Commercial use of data may be possible through direct permission of the institute that is responsible for the data requested. Digital object identifiers. In 2019, Intermagnet published its first DOI for the 2013 annual definitive data set. Intermagnet intended that DOI would become a standard means of data recognition and citing, for example, by minting DOI for each annual ERDS. Technical Manual. Version 5.0 of the Intermagnet Technical Manual will be available on the website from September 2019. Software. A number of software tools are available from Intermagnet for the easy checking, plotting, and manipulation of data. Intermagnet welcomes community development of tools and software and encourages contributions. Applications of Intermagnet data. Intermagnet data are used for a wide variety of applications, including geomagnetic field mapping, monitoring variable space weather conditions, directional drilling for oil and gas, aeromagnetic surveying, assessment of geomagnetic hazards including space weather, and fundamental research on the Earth's interior and surrounding space and atmosphere. Standard products utilizing Intermagnet data include magnetic indices e.g. KDST, the World Magnetic Model, and the International Geomagnetic Reference Field.